Okay, welcome to what feels like the year 2000 and some online Zoom classes. Nice. All right, give me a couple of seconds because I to just fix a couple of things. Okay, I think I'm all right. All right, excellent. So I think we're all set to go. All right, 9 slides total. So 7 things, well, actually only 6 things. The whole purpose behind today's lecture is just some examples of using dictionaries for real world problems. To be completely honest, I think we could probably combine sorry, we've got which day? It was Monday's lecture and this one together, and we'd have ourselves probably just one good solid hour and a half rather than breaking this up into two. But you know what? We will take this as a win, as something a little bit relaxed before we shift gears and do something sort of new and different and maybe more tricky next time. All right, first one up is I see I've already got a question about this in the chat, and that is, so hang on. You're sharing your screen. Okay, good. I think everybody can see this one. Okay, good. So right here, people are asking about the attendance. Okay, it's no problem. It's a quiz in section 1. It's called the October 29 attendance quiz. You can do that at any time, but the problem is you're not going to know the answer to the question until the very end. So yes, I am going to hold you hostage, or you're going to have to get the answer from somebody and then fill it out afterwards. So sorry, this is the only way I could figure out how to do attendance. All right, so here we go. Real world computer or real world problems using dictionaries. Okay, you'll have to give me a few seconds because I am not entirely organized. Okay, because it's been a long time since I've done this. Okay, if you started the quiz by mistake, just minimize it. Don't worry, it's not locked down browser, and just let it sit there. Okay, don't worry. Or you can take your chances and try to enter. Okay, yeah, it's okay. Just leave it. Don't worry. Just don't answer it. Okay, just minimize it. Come back to it later. No, you have to do the quiz during the lecture period. Okay, so it's there until 3:30. In other words, once we're finished, as soon as I'm finished, then it's fine. Then you can answer. Okay, so really probably don't start it until I'm actually finished talking, and you'll know when I'm finished talking because I will end the meeting. Then go off, answer the quiz. It's one question. It's not a very difficult question. All right, so now where am I going? Okay, I think I've got everything set, so let's go for it. All right, real world problems using dictionaries. Yeah, dictionaries were not just put together. There was a timer. It's closed. What? No, no. There is no timer. Uh, this is going to be like the longest, craziest thing just to even get us started. Do one attempt allowed. 2 minutes. Oh, yeah, you're right. There is. Okay. All right, so. All right, in that case, here's what I'm going to do. I'm going to hide this from everybody. Okay, there we go. And I'm going to go over to grade and I'm going to reset it for everybody. Okay, so here we go. Delete. So let me see here. There we go. I'll delete this one. And yes. Okay, there you go. It's all reset. I will open up afterwards. Okay, good. That's out of the way. All right, so back to my problem. Okay, yes, dictionaries are not just something that we invent to make students in 1201 have some issues. Yes, they are a little bit more tricky than some things. However, they're actually so critical that I would say that they're more important than lists. In fact, if I had to give up lists or dictionaries, I'd get rid of the lists because the dictionaries are actually that much more critical. All right, so I thought what I should do here today was to simply go through and do a couple of examples of why we might use these and some of the techniques that we use for dictionaries, because like the same thing I've said many times, there's usually patterns of things that occur, and that's the whole idea behind today is just to simply look at some patterns. All right, so first page up is it's all about using these things. Okay, good. Let's put this aside for a second because I don't like the next one because the next one just gives you the answer, and that's no good because we have to learn what it is we're trying to do. So I'd like to write the problem over here and then solve it. Hey, for once, I don't have to make the screen really, really big. Okay, excellent. So let me write up a comment. Okay, so I'll use the multi-line string, and let's do this. Um, Write a program to count how many times each word appears in a text string. Okay, now you give me a second because I am going to generate a string here off to the side. Sorry, I meant to do this earlier and somebody came in and bothered me. So yes, if you think I'm using ChatGPT, this is exactly what I'm doing. I'm using it to generate some random words. So okay, let's see what kind of crazy things we've got here. Punctuation. Okay, so I'm just asking you to give me a sentence with a bunch of repeated words and some no punctuation. All right, this works perfectly fine. Okay, so here's the thing. Okay, we have some text and here's a string. Okay, it says, I saw that cat, that boy owns Chase, that dog saw run away. Woof. Okay, it should have been easier to read than that, but that's completely fine. All right, obviously what we've got in here is we've got a whole bunch of words in a string. Okay, and my question is how many times does the word I show up? How many times does the word saw show up? How many times does the word cat show up and boy and owns and chase and dog and so on? All right, because obviously we might be interested to know which word shows up more frequently than all the others. And in this case, it happens to be the word that. And of course, we can read this by hand, but we'd be really interested in, say, writing some code that would do this for us automatically. It'd be certainly a reasonable thing. So what I'm going to do is I'm going to build this up, and the first little bit has very little to do with dictionaries, but eventually we do use a dictionary because dictionaries work really well for counting frequencies of things. And I will show you this, and I will show you another typical place where it would end up being used. All right, the text, well, okay, the text was just hard coded, but maybe the user typed it in and we asked the user, okay, what string would you like me to look at? And it goes off and it does this computations. All right, the first problem with this text is the fact that text is really just text. It's a whole bunch of words and a whole bunch of spaces between each of the words. But I can't even ask a simple question like how many words are there? I can ask a question like how many characters there are, because that would be just length of text, but that's not going to be good enough. I need something that would tell me how many words I've got. Okay, because once we get the number of words, though, then we can start to figure out how many times does a certain word appear inside my text. So one of the first things I'm going to do is I'm going to take this string and I'm going to break it up into a whole bunch of little tiny pieces, a bunch of words. Okay, and what I'm going to do is for right now, I'm just going to put this together without a function because, putting things into functions is not really that difficult. If I can figure out how to do this with a function, or sorry, without a function, then I should be able to just copy and paste all the code, put it into a function, and we'll be in good shape. So let's do it this way. I won't write a function for this time, but I will bring in a function as we go. All right, first thing I'm going to do is I'm going to comment it out because I want to include something that I don't know whether or not we have seen. I couldn't remember whether or not it was in the slides. Sometimes it's going to be in different places. So I'd like to take a minute to explain it. All right, so here we go. Let me have some words for a second. Okay, and oh, you know what? Well, of course, it's just so I don't mix myself up with words. All right, so we have INFS 1201, we have INFS 1101, we have, sorry, put a quote around that. We have INFS 2201, we've got DAX 2201, and we have DSAI 2201. Okay, and everything continues on. So there we go. I've got myself a list of strings. Okay, this is the thing that I'm not sure whether or not you've seen before. Let me make a new variable. Okay, and I'm going to put in here the variable quote space quote dot join. And I'm going to pass in courses. And I'm going to print the result. And I'm going to print the type of the result so that it's very, very clear what we've got. Okay, so here's what I just don't know whether or not you've seen the join function. The join function is something that applies to strings, and it does something really cool. What it will do is it will take a list of strings and it will build it up into a single string. And let me show you what it looks like. What it does is it takes each of the items inside the list and it joins them all together using a space. And you can see what I've got here between each of these is exactly one space. So it's kind of a clever way how to format a list of items to make it maybe presentable. For example, quite often we might use something like a comma between them. So that's what it looks like. This would be all of the words with a comma, or maybe you want spaces after each of the commas. Okay. Sorry, if you hear a big zap, that's me swatting a fly with my electric fly swatter. Okay, I've got one buzzing around my head. Okay, so it's a really cool way to format things for displaying. Okay, it's really, really helpful. Like, for example, sometimes you have things like this, you want to put X's between them. It's really kind of a clever little tool because it puts exactly that item between each of the items and it doesn't add one to the end. Okay, that's a join operator. All right, you probably don't see it very much in this course because just haven't run across very many uses for it. However, I think I probably should add it to the string review section, but it doesn't belong there because it really has to do with lists. So I think I'll add it. But in any case, the reason why I wanted to include it wasn't because I need it today, but I wanted to show you the opposite. Because what I'm doing here is I took a list of words and I joined them together into a single string. That's not what I'm interested in doing here. I'm interested in taking this text and breaking it up into a list of words. So let me show you the opposite of join. The operation is called split. Okay, and what you do is you say the character that you would like to split the string on. And if I now show you the words, and I will show you the type of words as well. Okay, when I run this program, you see what it does is it prints out a list, that's the words. And of course, the list contains exactly the words that are inside the string. All right, so that's the opposite. This is one of the things that we're going to have to do right at the very beginning is we're going to have to take this big long string and break it up into a bunch of words. Okay, so that's what I've done. Because once I break it up into a bunch of words, well, now I could start asking questions like, well, how many words are there? Well, we know to calculate the number of items that are inside a list, its length. And there you go. There are 16 words in that sentence. Okay, that's actually pretty cool. Yeah, we're not talking about duplicate stuff, but if you are interested in how many distinct words you have, hey, you know what? We might as well do this. It's not part of the question yet, but here we go. Distinct words. Okay, well, the word right here, distinct, this almost always indicates something. Remember, we've got a structure, a data structure in Python that looks after making things. And yes, that's exactly, oh, sorry. So there's a message that popped in asking, so split converts strings into lists. That's exactly what it does. Okay, thank you for the question. That was a question for everybody. All right, so the word distinct, as soon as you see the word distinct, you know what immediately comes to mind? Probably a set. And yeah, this is actually really, really cool. Like let's use some of the stuff that we've done. So you know that you can take a list of words and cast it into a set. And if I show you distinct words, if I spell it correctly, distinct words, okay, we run this. You see, now what I've got is I've got these. So the word that, which I wrote up a whole bunch of times, well, now it's only showing up once. And do we have other things in here? We have dog and boy. We might have to add a few extra items as well. But oh, saw. Okay, the word saw showed up twice, but it only shows up once in here, which means that if I wanted to figure out how many distinct words I've got, well, it's only 10 of them. So there's 16 words in total. 10 of them are completely unique. Okay, so there are 10 unique words. Now, of course, if my problem stopped at this point, that would be great, but I'm really looking to figure out how many times does each word appear in the text string. So I need slightly different information, and this is the place where a dictionary comes into place. Okay, and this is always a standard mechanism. And if you take a look at the slides already, you're going to see this because, well, it shows up because it's exactly how I'm going to solve the problem. It just happens to be that what I solved in the slides was quite a bit more complex, and I will make my string complex. But give me a few seconds because I want to bring up something to deal with this. All right, somebody's just asked, is there anything to do for the attendance? Yes, you will have to answer my attendance quiz. I can't make it visible yet because people will start it. So sorry, you'll have to wait. I will set up the attendance quiz just at the very end. So if you're going to disappear, You're going to have to make sure that one of your friends is here, and they're going to have to send you a very quick message to say, it's done, answer the quiz. Okay, that's what you're going to have to do. All right. So, of course, I'm not supposed to encourage that, but hey, I know it's going to happen. All right. So here we go. Let's go and figure out what these words are. So I'm not interested in these things right now, but hey, you know how this works for W in words. All right. I'm just going to print W. All right. When I run this program, of course, what I see is I see each of the words split according to the space. So what I've got is I've got a list of words in here and I'm going through and I'm just printing them. Now that's cool because at least I can go through and look at it, but how do we know to count this? Now, if I ask the question, how many times does the word that appear? Well, that would be no problem because what you would do is you would do something like this. So I'm going to come up with a bunch of ideas. You might have something like this. A counter is equal to 0, and you might put in a question like if W is equal to that, then you'd say the counter goes up by 1, and at the very end, you print the counter, blah, 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 and you get the number 6. Of course, that's not the problem. The problem is I have to do the same type of counting for every possible word that's in the dictionary. So does this mean that I'm going to have like a variable called that counter? And followed by if W happens to be equal to cat, then I would have the cat counter going up by 1. This would be absolutely terrible. Okay, this would be absolutely terrible. The attendance quiz is a true false question. Okay, it's just a true false question. It's basically asking you, did I do something today? Okay, so you had to pay attention. All right, so here you go. So would we solve it this way? And the answer is no, we're not going to do that because we have absolutely no idea what type of words are going to show up. But we do know the words because they're W. And the usual mechanism that I use for counting word frequencies is I use a dictionary. Okay, good way to freak them out. Yes, it's coding. You have to write a 59-line code to find out whether or not you were here today. Excellent. Whoever suggested that, you can do the grading to make sure it was actually done. Anyway, here we go. Let's go on. Hey, excellent. Okay, so let's go at this. This is the typical way. What I would do is I would have a frequency chart. It could be called a frequency table, et cetera, et cetera. But here we go. We're going to build remember what this is. This right here, this is not a set, right? If I put a single number in here, now it's a set, but now it's a dictionary. Whoops. Okay, so that is a dictionary. Here's what I'm going to do. I'm going to build up a dictionary that looks kind of like this, but I have to do it programmatically. You see, I'm going to have a dictionary where I might see a result like this. The word that appears 6 times. The word cat appears 1 time. The word dog appears, and so on, so on, so on. That's what I want to reach. Okay. But we're going to start by having absolutely nothing in the frequency dictionary. Now, here's what I'm going to do. I'm going to write a little bit of this. You see, I'm going to go to the frequency dictionary, frequency, and I'm going to go to the word W, and I'm going to set it equal to the number 1. Now, I'm going to run this application. Sorry, I'll print out frequency, and I'm going to show you what the result looks like. You see, it found the word I, it found the word saw, it found the word that and cat and boy and owns and chase and dog and ran away. It found all of those, and of course, well, it set 1 to each of them. Okay, excellent. So one of them is now, we have realized that there's 1 of each. Okay, that's fine. But unfortunately, there wasn't just 1 of each. Some of them had more than 1 item. So what I'm going to do is I'm going to make the following rule. I'm going to say if W is not in frequency, then I'm going to add it. Okay, now kind of a bit of a weird thing. Yeah, I kind of did it this way. So if W is not in the frequency, add it. Oh, and by the way, if I run the program, it still looks the same. Oh, sorry. Sorry. Is. What am I doing? Pretend you didn't see that. Erase that from the recording, please. Okay, it's fine. Sometimes you forget what you're doing. But here we go. If W not in frequency, I was reading it right, just not typing it right. All right, so if W is not in the frequency, just go ahead and add it. Okay, that's fine. That's how you get the first number. But what happens if it is already in the frequency? Okay, well, this would be the else case. Well, what I'm going to do is I'm going to take the frequency at W and I'm going to take the old frequency at the position W and I'm going to add one to it. So you see, the first time that I see a word, I can record it as a one. The second time I see a word or the third time, I add whatever is there. And the really clever thing now, you can see that the word that appears six times, the word saw appears twice. Okay, so there we go. It's some ideas. Okay, it's some ideas. Now, that is a frequency distribution, and that's actually what I was attempting to run out of this. There's kind of a much more interesting and difficult problem. I'm going to leave this for, okay, I remember seeing this in one of my first courses I took in university. The instructor wrote this down on the board. He wrote down a problem, and it went something, well, it wasn't this problem, but we'll say figure out which word appeared more frequently. Okay, frequently. All right, and the word obviously is that, but write the code for it. Okay, you're looking for some exercises to practice dictionaries for the lab exam. There's a good one to get you going. Now, what my prof had written down is he wrote in parentheses something to the effect of LTIS. And he said, then if you don't know what this means, that says it's left to the interested student, which of course then he joked and said that there was no such thing. All right, but honestly, that this makes a really good exercise. How do you, I mean, we can tell that it's a six. Write a function to do it. Okay, it's probably worthwhile trying. There's some techniques about how you can do it. You don't have to answer it right now, but hey, it would be a good exercise to work on. All right, now the exercise, if we take a look on the slides, it's actually a little bit more complex. Oh, and by the way, this is a very typical thing that we end up using for doing calculations of how many times does something appear. This is exactly what we end up doing. I'll put it into a real context in a second, but I would like to make some extra changes. Um, okay, how about okay, let me add the word dog to it. Okay, now it doesn't make any sense because now it says dog saw that cat that boy owns chase that dog. Okay, it's really horrible. It sounds like the audio is skipping on my Zoom connection. Okay, yeah, that's what it sounds like. All right, but in any case, let's run my little frequency checker to see how many times things appears. All right, you'll notice that the word dog appears once. No, it's supposed to appear twice. Yeah, the word dog with a capital D appears once, and the word dog with a lowercase d appears once. So they ended up with two different things because, of course, they are two different words. All right, the way how you deal with this, there's a few different things you can do. The most typical thing, I mean, this has more to do with string manipulation. Probably what I would do is I would take, or sorry, not test, I would take the text and I would say to lower. And I type the word test again. All right, here we go. And sorry, it's just lower. Sorry, wrong course, wrong language. All right, it's the function lower. And what it does is it takes any uppercase letters and it lowers it down. So now the string text contains only lowercase, which means that when I'm trying to look these things up in the table, well, now the uppercase, lowercase thing is completely ignored. Now, to make things considerably worse, what happens is somebody starts putting in things like this. And let's see, we'll put something at the very end. Okay, cat. Oh, sorry, let me put the comma right here as well. Okay, this is, go away. This is a bit of a more of a problem. Okay, so let me clear the output and let's run this to see how it appears. When you execute this, you might be a little bit disappointed about some of the results. Like, for example, if you take a look at the word that, well, it only appears five times now. Well, that's because unfortunately, when we did the split, we said split on spaces. And as a result, I ended up with that comma. So this word right, this became a word. And of course, that doesn't make any sense. All right. So if you wanted to get rid of all the punctuation, Again, it could be one of these things. You could take this and you could say, you know what, I would like to replace the following things. Like maybe full stops, commas, semicolons, exclamation marks, all of these things here. I don't even care what we've got in here. You could fix everything. Maybe what you want to do is you want to replace those with nothing. Okay, and what that does is that actually gets rid of all of the items. Oh, maybe not quite. So maybe not the best. Okay, so let's see what we're doing. Okay, so unwanted. Yeah, you see, here we go. I made this a little bit more, unfortunately, although that works in some languages, it's a little bit more like this. So let me print out the text just afterwards. Okay, so after the replace, you'll notice that it got rid of the commas. Oh, but then I have some explanation marks that I want to get rid of. And really, the first one that I tried, that's what I would really prefer. It just happens to be in Python, replace. Okay, let me do a replace. Here we go. You see, what I'd have to do is I'd have to go and clean up all the unwanted stuff, if of course, then turn it to lowercase, and then we can go on with it. Okay, so there's a quick little request in here just to remind you what the split does. The split will take this big long set of, or this big long string, and it will break it up into a list of strings. Where the space is used as a split item. So in other words, if this was in a string, I'd end up with two results in the list, which was chase and that. Just in case you joined in a bit late, if I print out the words, for example, and run it, here we go. That happens to be just all the words. Okay. All right, so there we go. Now, how do we solve this kind of a bit more generally rather than what I'm doing? Okay, and the issue happens to be that the replace function only works with a single character. I wish it would work with this. And there are lots of languages that do this. Okay, it just happens to be that this isn't one of them. If I show you, there we go. If I show you the slides, take a look what I've done here. Okay, what I did was I called the function get words, and I passed in a whole sentence, which was some long sentence. It wasn't very exciting here. And you see what I did was I made it all lowercase, and then I said, okay, go through each of the characters that I'm not interested in. So I was interested in new line characters, decimal points, semicolons, commas, exclamation mark, colons, and question marks. Add whatever you want. And what I did was I looped over and I said, keep fixing it, keep replacing the unwanted thing with an empty. Finally, once you have it, split everything based on spaces. All right, and then what did I do? I came down here and I did exactly what I just described. Yeah, it's the way how we calculate frequencies of things. Let me put this into another case because you know what? This is something that we just did. Give me a second because I'm going to ask my good friend over here, ChatGPT, to give me some test scores. So give test scores in a Python list. Scores between 0 and 100. Give 20 of them. Okay, so here we go. Excellent. Very good. I'm quite happy it's here. It's like a really nice assistant. All right, so here we go. Here's a list of scores. I'll press enter a couple times so we can see it. And I might want to know, for example, how many scores, build up a table, how many scores are A's? Like maybe there's 23 A's, maybe there's 10 B's, maybe there's 67 C's, this type of thing. This is exactly the same idea that we just solved. And we always solve it the same way. We use a frequency table, or sorry, a frequency dictionary, okay, in order to figure out where things are. I won't solve all of it, but I'll at least get it kind of started. So here we go. I'll call it a grade distribution. And I'm going to start it off as being an empty dictionary. I'm going to go through all the scores in, or sorry, all the scores in the scores. And right now I'm just going to print it just to make sure I've got it. Okay, good. So we got all the scores. But what I'm interested in doing is I want to classify the scores. And I would like to say if 90 is less than or equal to S is less than or equal to 100, then what I'm going to do is I'm going to go to the grade distribution for the grade A, and I am going to add 1 to it. Oh, but I can't do it yet because it isn't there. But what I can do,
Professor,
I can start at 0. Yeah, go ahead.
sorry. مش how can I access شو اسمه The frequency table.
The- Um, well, remember, this is just a dictionary.
Ah, okay. Okay,
Yeah, this is
sorry.
just a dictionary. Okay, so you see what I'm now doing with my dictionary is I've started this off as A's because before I start processing the scores, I've got absolutely nothing. And see what I've done? I said, okay, well, if the grade happens to be between 90 and 100, it must be an A. Let me print the grade distribution. Distribution. All right, and yeah, there were five A's. Well, at least they're according to up here. Yeah, there were five A's. Well, what if we wanted other things? Well, if we wanted other things, what I could do is I could start off with B's. And it would really be just a matter of me tossing in another one saying, okay, if it's less than 80, less than or equal to, sorry, directly less than 90, then I could say that the grade distribution, okay, if you got a question, I'll stop in a second. This could go up by one as well. Okay, so here you go. And obviously I've now got four B's. Okay, question? It gives me a second to drink too. Okay, no issue. All right, so and could I continue on? And the answer is yeah. I just have a bunch of extra if statements. Now, if your question is, well, wait a minute, so you said it before. If you're copying and pasting something a bunch of times, there's probably a better way to do it. Yeah, I think there is actually better ways to do it. I think, unfortunately, if I go down that route, I might not get through the other examples. But if you want, go off and give it a shot and see if you can come up with some kind of a clever way where you might be able to do this in a better way without having to do quite so many if statements. There's some really clever things out there. I believe it's a little bit beyond what I would normally put in 1201, but it could work. All right, and yeah, you can certainly add the A's and B's and C's dynamically, just like what I did. All right, it's almost the same technique. We take a dictionary, and the thing that we're interested in becomes the keys, and the distribution starts off at zero. And whenever we see that item, we add one. And remember what I've said, these are programming patterns. Once you see a frequency calculations once or twice, you realize that, oh, they're actually not that much different than each other. And at this point, then you can use this for everything. And if you say, yeah, but it's not a really useful thing, all right. Well, again, I like to always try to tie things together with reality. Um, I hope everybody enjoys using AI. I mean, yes, it is certainly really interesting. It does a lot of cool things. AI is based on machine learning. Machine learning is based on probabilities. Probabilities are based on frequency distributions. Okay. And frequency distributions can be calculated this way. Okay. So, yeah, everything does kind of tie together. So, if you say that, no, I'm an AI, I don't need, yeah, well, actually, no, this really is your life. All of these models you're going to learn about in the DSAI 2201 course, which I know everybody's doing um, is going to be you have to deal with these types of things. The good news is it happens in the background in a lot of cases, but you do have to understand what's happening. Okay, somebody's asking about the quiz of his lockdown browser. No, no, you can cheat all you want. You can even ask ChatGPT because it won't know the answer to the question.
Mister, I
But
have a question.
oh, sure, yes.
If we use AI, it's okay. We won't be banned.
For which purpose?
This one. Oh,
Oh, what the attendance quiz?
yeah, yeah.
Yeah, okay, good luck. Okay, let me know if that works out for you.
Okay.
Okay, I would be quite surprised if it gave you an answer. Maybe it will take a guess on something and maybe it'll be right, but probably not. All right, don't freak out by the quiz. Okay, all you have to do is just answer the quiz, no issue. Okay, just answer the quiz. All right, so it's a simple true false. Okay, I won't even make any further comments about this. Where did my slides go and what time is it? 2:34. We have to keep working. All right, so there we go. That's the first one, word frequency counter. Okay,
So
oh, yeah, sure. Yep, go. No, okay, not a problem. Okay, over here. All right, grouping and aggregating. Yes, is what we use it for. That was calculating who's got the A's, how many B's, how many C's. Okay, so in this case, what I was doing was I was appending things. You know what? I don't mind running this one. Okay, I won't type it, but I don't mind running it because it's kind of interesting and we can mess around with things. All right. At the very end, I just want to print the item called bands. Okay, so take a look at this. What I've got is I had a bunch of grades, okay, and we made some decisions about whether or not the score was an A, B, or C. And instead of having as a single value, I stored a list, empty list to begin with. And every time that I found a person with an A score, I appended the name to it. So that's kind of clever because what it does is starts to amalgamate things. This is a very, very common pattern as well. Okay, it's a very, very common pattern. So to say it's lists and not a dictionary. Same as the one, is it the same as the one inside the slides as a list? I'm not quite sure I get this one. But this is a question about the quiz. Don't worry about the quiz. Don't worry about the quiz. It's just a very simple question. Okay? Yeah, don't freak out about this. Just watch the slide, just watch the presentation, and you'll figure out whether or not how to answer the question. Okay? Yeah, I've hidden the quiz because people tried to run it already and they don't know the name. Okay. Ooh. And now what have we got? The comma is used how? Ooh, okay. Hey, I don't mind answering this, but I know I answered it the other day. Hmm. Okay, let me remind you. Okay, for X in grades, print X, and I'm not going to print this one. All right, this is a review from the review from Monday. All right, if I print X, what do I see? Okay, well, let me run it, and hopefully you remember. You see, when you iterate through a dictionary, you pick up the keys. If you say dot values, not a big surprise, you get the values, which of course are the things that show up afterwards. If you use the items, you end up getting a tuple. Okay, well, one tuple for each entry. Each tuple contains the key and the value. So this is Ali 85, Sarah 72. That's where this is coming from. If you were to do something like this, because what do I have here? Well, what this is the name of the student, and the second item is the score. And I prefer that because then I can do something like this. So here, let me write a small program, and I'm going to write out just the good students. So let's say that good students are students with 80 or higher. So let me do it as X. Okay, if X at 0 is bigger than or equal to 80, sorry, wrong course. Sorry, I was doing Java earlier. Print X at 1. All right, see what we're doing is this is a tuple. Tuples have position 0 and position 1. What this would end up doing, oh, sorry, if 1 print 0, sorry, getting this backwards. You see what I'm doing is I'm checking the grade to find out if it's bigger than 80, and then I'm printing the name. Now, although this works, I really don't like this format because it has the word X and it doesn't really mean anything. Instead of storing it as a tuple called X, what I'm going to do is I'm going to store it as a name and a score. This is called tuple unpacking. Tuple unpacking means that I can now ask a question like, if score is bigger than this, then print the name. And that is less likely to cause you problems because I had that issue. Okay. In fact, I even just had that issue a second, but you can see that this makes life a whole lot easier to understand. So that's what the tuple is here for over in this other function. Okay. In this other program. All right. What have I got next? Ooh, okay. All right. Maybe what we'll do is we'll run this one so we don't, but can't be used in. So it's only in dictionaries. Yeah, yeah. Okay. Very good. All right. This one right here. Yeah, this is something only for dictionaries. Okay. It doesn't work for lists. It doesn't work for tuples. It doesn't work for sets. This is only a dictionary. Okay. Thank you. Good idea. All right. We've got another program in here. I will save the time from typing it. Okay. I'll copy and paste it just so we don't burn up too much time. I'd like to try and finish this up by 3 o'clock today. So I won't type this one, but we will run it and we'll make some modifications. We'll do it for the next one, and then I will do the case study entirely from scratch. All right, let's take a look at what this function, or try to make a prediction about what this program is doing. All right, first thing up is we have a data dictionary, and you can see that the keys are the students. Okay, that's fine. We got the keys as the students. The values Oh, are dictionaries as well. So yes, this is a nested data structure. It's a dictionary of dictionaries. By the way, your assignment is also a dictionary of dictionaries. These are, I'm going to describe them as really legitimate exercises. This is real life stuff. A lot of the things that we do here is, I'm going to call it in 1201 is kind of fictitious because they're too simple. But once we start to get nested dictionaries of dictionaries and dictionaries with lists and lists with dictionaries, these things are more realistic and you will be able to deal with more realistic problems. Okay. Okay, thanks. Whoever's answering, good.
Mister,
Thank you. Thank you. Thank you.
Mister,
Oh, sure.
I have a question.
Oh, sure thing.
Question.
Yeah.
Your name is Mister or Mister Lamborghini?
Yeah, great. I haven't heard that one for a while. What I used to hear in school a long time ago was this word right here, Chevrolet. My Yeah, I see that. Okay, yeah, that's fine. That's fine. We can ban them if we want. Yeah. Anyway, so that was that name has shown up before, so don't worry. All right, here we go. So inside our data, we have got a bunch of students. And for each of the students, I've got a bunch of courses. I've got some grades for the math course and grades for the CS course. All right, let's see if we can understand and sort of unpack what's going on. First of all, I've got this dictionary here called totals. This is like kind of working in reverse. Normally we give a problem and then we try to find some code. This time we've got some code, we're just trying to understand it. You see, when I go through all of the students and I look at data.values, well, you know what? You've seen me do this before. I would like just to see what's going on inside. So what does it look like when I say student? Okay, what I get, okay, you have to ignore this one down here. Here you go. What I'm getting is a bunch of dictionaries. I don't think the word student is really that great of a name because really what these are grades. Okay, but in any case, we're going to leave the variable that's here, but that's what each of these things are. I'll leave the print statement in for now. Because student is a dictionary, take a look at what I'm doing next. I've got the subject and the score, and I'm iterating through student.items. Well, we just saw that. Let's print out subject and score. There we go. So you can see this was the original dictionary. Now what we're doing is we're going through, okay, so hey, at least somebody is there. Okay, so who is that? Do, do. Let's see, over there. There we go. Excellent. All right, so that person is out of here. All right, so here we go. We're going to go through, we're going to print each of these guys, okay, and we're going to print out the items that are inside. Now, what are we doing inside here? Now, I've got this operation here called get. The word get, of course, is used in order to get a certain value. So in other words, I want to get the subject. Okay, for example, I want to get the math score, I want to get the CS score. All right, well, why did I use get instead of the square brackets? Well, because sometimes we end up in situations where some students have a course and some students don't. And remember that if you were to use the square brackets and something isn't there, you end up with a key error. So that's the reason why what I've done here. Let me undo this. Let me get up my print statements and let's take a look and see what happens with the totals. I'm sorry, wrong button. Let's go off and run it. So you see what I've done is I've gone through and I've basically said, hey, look, how many maths do I have? How many CS do I have? Now, at the moment, this is kind of silly because all that I've done is I've just gone through and I've added up everything. All right, what would you do next? Well, chances are what you would really do is you'd go through and you divide it by the number of items so you get the average. Okay, and that's just missing from here. So that's one extra thing. It says the slide says average scores per subject. Well, it says sum or average slides per subject. This is currently the sum, but we could then go back through and we could calculate the average. Okay. All right. So there we go. That's the next slide. And then I've got one final slide. Oh, sorry. Got this one right here. This is another reason sometimes why we use dictionaries. This one is very, very nice. I use this all the time. Okay, so let's write up a small program. And let's say int, sorry, month number is equal to int input. Yeah, I know we hardly ever do this. Enter a month number. Okay, so we got ourselves a month number. Now, let's suppose that once the person types in the month number, say 10, we would like to see the word October. All right, this is an INFS 1101 problem. And you know what this would look like. You'd probably say if month number is equal to 1, then you'd print January. Okay, and then you'd probably have an L if month number is equal to 2, L if month number. Okay, yeah, you could do it. And remember, I have said these types of things before. Yeah, if you copy and paste something a whole bunch of times, there's probably a cleaner way to do it. Okay, and this is exactly one of them. This is a trick I use quite often if I'm trying to convert numbers into words, and that is to have something called a lookup table. Okay. And here's what I'm going to do. I'm going to have a dictionary. One is going to be January. Two is going to be February. Three, and guess what, is going to be March. Now, I'm not going to write all of them, but I will write 10 as being October. All right. And 11, November. All right. And here we go. That's the end of my lookup dictionary or my lookup table. Let me print this for a second just to make sure that I have no issues with it. So let's do a lookup table. Okay, so sorry, 2. There we go. There's the lookup table. You see, if I wanted to know what the name of the month was for 2, all that I have to do is look it up. Okay, so enter 2, February. Excellent. Enter 10, no problem. October. Run it again, 11, November. Pretty neat, right? Unfortunately, if I type 12 right now, it says key error because, well, I didn't actually add it. But you see, this is a lot nicer than a whole pile of if statements. And yeah, there's probably other ways of dealing with this as well. I could easily do this with ID numbers and students, and I believe that I did this in class one day. If you replace these with actual ID numbers and these with the names of the students, you can look up the values very, very quickly. It can avoid a lot of if statements. It really does make quite a bit of a difference. Again, just another reason about why we might use dictionaries. It's another purpose. All right, this one over here, one case study. So we're going to solve this one. We'll have to do it from scratch. This one is probably a bit easier to say than the summation of the grades. That was a little bit tricky. And what I've got here is I've got an array of dictionaries, and somebody says, okay, we want to go through and we want to calculate all the snacks and all the drinks. Okay, so how do we solve one of these? Well, hopefully you kind of recognize that the problem is very close to the exercises we've already done today, which is it's an aggregation of something. You see, I have to go through each item to find out, is it a snack? And if it is, I have to add, say, 250. The next item I run across is a drink, and that's $1. Next item, I find another snack, 125, but I have to add that to an existing item. All right, well, let's go off and give this a shot. Okay, so here we go. I will grab this as some data. So here we go. Here's a shopping cart. Let me break this up so it's easier to see. So we'll break it here, here, and here. And we'll put one over here as well. All right, and the same thing as what we've done before. I could put this into a function, and the slides actually show the solution as a function. But for this one right here, I'll just solve it out in the main program. All right, the first thing that I would probably start with is, well, what if we just print everything? So for X in cart, what would this look like? Just see what we've got. Oh, okay. It's not a big deal. It's just simply all the values. What would I call each of these things? Well, I would probably call them items. So for item in cart, for item in cart. Okay, so same output, just I've now got a better looking variable name. Now the thing that I have to do here is I have to figure out, is it a snack or is it a drink? Or is it something else? Well, let's start this way. And then we'll talk about how we can make this really, really flexible. You see, items always have a category. So let's have a variable called category. That would be item at category. I don't actually need the variable for this. In fact, maybe I won't. Okay, in fact, let's do it this way. let's just use an if statement. If the item category happens to be a snack, well, then what I'm going to do is I'm going to print the word snack. And while I'm here, I'm going to print the item as well. Okay, and hey, we kind of did something like this before. If the item category is equal to a drink, then I'm going to print just the word drink, and I'm going to print the item. So take a look what you got. So this is being able to identify each of these items. Well, I'm not interested in the entire thing. I'm probably just interested in the price of the item. Okay, and the price of the item. So when we use something like this, no, is something very, very different. Okay, don't use it. That's my comments at the moment. All right, so just use the double equal sign, please. All right, so here we go. What I'm doing now is I'm managing to categorize things as a snack with a value of 2.5, a drink with a value 1, and a snack with 2.5. Oh, okay, so how can we somehow or another add these together? Well, we've been doing this already. It's the same idea about using these frequency tables for counting things. In this case, it isn't frequency, it's actually just like a summation. So maybe what I'd want to call this might be maybe the totals. I'll call it totals. But rather than the total just being a sum of everything, I want to break it into the different categories. And if I know that I have snacks and I know that I have drinks, I can start it off at 0. And instead of printing these things directly, I could say, go to the totals given the category, which is spelled this way. So sorry, it's a double nested item. Okay, so remember this one right here, this will be either snack or drink. And what I will do is I will add to it the item price. And I'm going to do, oh, sorry, not the item category, sorry, the snack. I wanted to keep this as simple as possible. I will make this adjustment in a second. All right, so here we go. We're going to do this one, and we're going to do the same thing here for the drink, except instead it's going to say the word drink. Okay, let's run this at what I've got for right now. So print the totals. Do I have it? And the answer is yeah, I kind of have it, but here's the issue. It's a pile of if statements. It isn't that I don't like if statements, but the problem with my program right now, if somebody comes along with a brand new item, let's see, a drink, maybe name, okay, and what should I be saying? Okay, lettuce, and category veggie, and the price, sorry, spell it the same. If it's not spelled the same, things can be really bad. And 3. According to this, according to the shopping cart, by the way, the most important thing is to avoid vegetables because they're really expensive. Oh, and no, I'm not saying that. The health people will get angry at me. The problem is if I try to do something like this right now and I add something new, it doesn't work. Well, it doesn't work because I typed a decimal point. If I try running this, it doesn't work. And that's because, well, I don't have an if statement in here for veggies. Okay, what do I do? Copy and paste. Oh, okay. Copy and paste. If it's equal to a veggie, then I will copy paste this in as a veggie. If I try running this, it blows up because I forgot to initialize it into 0. Boo. Okay. So not bad, not bad, but it's a lot of copying and pasting. But does it have to be a copy and paste? And the answer is no, it doesn't have to be a copy and paste. We can use the same technique that we saw right at the beginning when I was counting word frequencies. That's why I showed the word frequencies right at the very beginning. You see, what I've got here is I've got a category. And is there something easier? And the answer is, of course, there is. I'm going to use this category in a variable, and I'm going to have a variable called price, which is price. That's just to make my program a little bit easier, okay? All right, and I'm going to ask the question, just like what I did before. If the category not in totals, I am going to take the totals at the category, and I'm going to set it equal to, oh, well, price, because that'll be the first one that I've seen. Otherwise, I'm going to go to the totals at the category and I'm going to increase it by the price. Now, here's the really cool thing. I don't need to initialize this to anything. I can start it at completely empty. And as a result, I get some really cool things. It's automatic. And of course, I can come up with whatever categories I want to call the veggies. Hey, yeah, it works just fine. And no, I'm not bashing vegetables. It just happens to be that it was very quick to move this around. And I know that people don't like vegetables nearly as much as, say, well, chips and soda and cookies. I mean, those are better after all. All right, but in any case, yeah, now it's kind of automatic. So if I start to add new items in here, they will automatically increase. And this little pattern, as I said, we've seen this a couple of times now as we're iterating through and we're adding to a total. And the reason why I'm doing this is I want to find out, is it missing from the totals? Because look, if I print totals right now, okay, the very first time that I go through the loop, the totals is empty. So I wouldn't be able to do this if there was nothing. Because if there was nothing, I'd get a key error. So what I have to use this if statement for is to basically initialize it. When I was counting word frequencies, I initialized it to 1. And I increased by 1. But this time, because I'm doing summation, I added the price. Just give me 1 second.
تجي في البيت شفتها يا ابن الحلال كل الافلام اللي قالها في مواقع متخصصه.
Okay, sorry about that. And who wanted? Yes, I will certainly report that. Thank you. Okay, good. So that person is hopefully gone permanently. Okay, so sorry for the message that appeared there. All right, so I will find out who that was and report them to the university as well. All right, so hopefully we'll be able to track that down. I should have access to emails, or not just the name. All right, so here we go. So that was the one. Wow, so many years of online classes, and I've never had that issue before. Anyway, so really sorry about that. All right, so here we go. So categories totals, and of course that's exactly what I just ended up doing, except that I stuffed it inside a function. All right, so there you go. There's some work with some dictionaries. Okay, so that was the whole purpose of the day, was to go through, here's a couple of different ways how we could use dictionaries, a couple of the different types of problems that we run across. The amalgamation of things, this happens all the time. So this little pattern about going through and adding something and then adding something to it, this is what we're looking for. Okay. All right. So I believe, given what's happening, I don't think we can actually continue any further. Okay. But it's good because I think we've actually got everything. All right. So I think we better stop this one. All right. So here we go over to, give me a second. Manage quizzes. Okay. So thank you for the patience in running this thing in an online. The October 29th attendance quiz, it's pretty simple. Go in, please answer the question yes or no. Okay, well, it's a true false question. You have a whole 38 or 31 minutes now. I don't believe that you'll have to go and ask ChatGPT about this one. All right. All right. So that's all. Oh, I guess if you get the quiz wrong, I guess you weren't here. All right. If you get the question wrong, okay, here's the deal. If you get the question right, I'm going to mark you as being attended. If you get the answer, if you get the question wrong, I'm going to take 5 minutes off and say you left 5 minutes early. There's your threat. So don't answer it wrong. All right. So all I'm going to do is I will shut down the Zoom session. The quiz is open for half an hour. Just please go in and sign it. And if you're there, I'll mark you as present. Okay. So even Well, if you don't answer, you're not going to be marked present. All right, so I will see you guys back in our regular classroom. Well, I hope so. I hope we don't have to do this again. I'll see you on Monday with some new stuff. Okay? All right, guys. I'll catch you next week. Oh, by the way, just before you take off, don't worry, it's not a big deal if you have gone. Um, Oh, if you answer it wrong, I'm going to take 5 minutes off your attendance. You'll still be here. You're just gone for a little bit. All right, couple things in here. The just to show you what I've done. Okay, student resources. Student resources. There is now a document here called Lab Exam Past Problems. What this is all of the this is all of the problems that I could find over the past several semesters. Sorry, it's a little different in scope because previously they never included dictionaries as part of the lab exam, but we will be this time. But I did give you an AI prompt. You can copy and paste this into ChatGPT, and you should be able to generate lots of questions that are pretty good. So everything is here. Chances are you probably had these things already. Sorry, did I say midterm? Sorry, not midterm. Lab exam. Chances are you've probably seen them already because I know lots of people have copies of them, but now you have them officially. Okay, so yes, I actually going back and solving existing problems is actually a pretty reasonable thing. Okay, so you have all of these. There's another section of content as well. It's called the practice questions. You can use these. There's some things called lab test practice questions, and there's some programming dictionary questions. Yeah, all of these are probably in scope. I find the questions are not quite as robust as the ones that I gave, but yeah, I certainly do lots of these. Um, yeah, I paid attention. Oh, here we go. What's the most reliable way of solving questions? That includes everything. Lots and lots and lots of practice, especially in these exercises. And of course, don't forget the assignment. And I don't mean don't forget the assignment because it's worth 5%. We'll obviously do that. But the questions that I put inside here are also really good exercises for the lab exam. Okay, so this is what I'm looking for. All right. I think that's all. All right. See you everybody back in class. And as I say, sorry for the disruption that ended up happening in here. Okay, so quiz is open for another little while. Just answer. Okay, don't worry about it. Just answer the quiz. You'll be marked present even if you get the wrong answer. Although you should know.